last section of this unit is called quadratic applications. Basically, it's all word problems. All the word problems are going to be two types. So they're going to be problems that really we're skipping these quadratic equation models, consecutive integers. But I guess the quadratic equation model is the time that it takes for an object to fall, or other problems involving the height of an object. We're going to be solving things using geometric figures, but we're not doing the consecutive integer problems, and we're not doing the Pythagorean theorem problems. So solving problems given the quadratic equation model. Let's say that we know that a pitcher can throw a fastball underhand at 63 feet per second. If she throws a ball into the air with that velocity, its height h in feet, t seconds after being released, is given by the formula h equals negative 16t squared plus 63t plus 4. After the ball is thrown, and how many seconds will it hit the ground. So this should feel a little confusing. Basically, what we're going to have to do is take h, replace it with 0, since that's what it means for the ball to hit the ground, and understand that this negative 16 really represents gravity, this 63 represents how fast they threw it, and this 4 represents where it starts above the ground when the pitcher starts to throw it. If we know that 0 is what this is equal to, we're going to use factoring to figure out how to make the right-hand side into two things being multiplied, that we can then figure out what t would make it 0. So the way this would look is we plug in 0 where we see an h. Once we plug that in, we'd see, wait, we have a negative sign in front of the squared term. I don't like to have the negative there when I'm doing the cross method, so why don't I multiply the whole thing by negative 1 or divide by negative 1, however you want to see it. Taking that negative 1 out, we're then left with 16t squared minus 63t minus 4. I can apply the cross method to this, do first times last term. 16 times negative 4 gives me negative 64. So I'm looking for two numbers that that multiply to negative 64 and add to negative 63. That would be negative 64 and 1. I could then split this using the grouping method and finally figure out what the factors are. Doing all that work would get me to 16t plus 1 and t minus 4. Once I have those two factors, again, by doing the full cross method to this problem, getting it to factor by grouping, getting it to insides times outsides, this should be outsides, this should be insides, and that should be the final factored form that we then say what makes this equal to 0. So we have 0 over here, we know 0 equals either this factor, because if this all equaled 0, wouldn't matter what this was, multiplying it by 0 would give me 0, or something that makes this 0, because again, it would make the whole term 0. So either 16t plus 1 equals 0, or t minus 4 equals 0, or possibly both. When I try the first one, I subtract 1 from each side, I get 16t equals negative 1, so that when I divide each side by 16, I get t equals negative 1 over 16. For the second way, I just add 4 to each side and get t equals 4. I now really want to consider what each of these answers means. Negative 1/16 second before the girl threw it doesn't really make sense in the equation. She's probably winding up at that point. It's not following the same formula. Really, in general, we can't consider negative time or negative variables in general for these types of word problems. What we can consider is that after 4 seconds, it looks like it came back and hit the ground. So, since we cannot have a negative time, we discard the negative 1/16. The solution is that it's 4 seconds after being released. If I put 4 into this equation, I do get 0, which means I did find the proper number of seconds after which she releases it, the ball will hit the ground. We also want to do problems that involve rectangles. Here it asks you to find the perimeter of the rectangle. I don't think I asked you questions that go quite that far in the homework. Basically, I ask you to find either the length, width, or both from knowing the area of a rectangle. That said, we're going to follow the same general ideas as what we're going over in this problem. So assume that a rectangle has an area of 52 square centimeters. So this whole rectangle is 52 centimeters squared. What that really means is this width, or however long it is in this direction, times this length, or however long it is in this direction, must equal 52 total. So if we're further told that its length is 1 centimeter more than 3 times its width, what we can set up, if we set the width equal to W for width, then the length must be 3 times that W plus 1 centimeter more, or 3W plus 1. What this allows us to do is use the formula A equals L times W and get it in terms of a single variable. So this 52 is the area that goes in for A. Width can just stay as a W. Length, I'm going to plug in this length formula of 3W plus 1. What that means is our formula becomes 52 equals 3W plus 1 times W. The next thing that I'd want to do is distribute that W on the right-hand side. So W times 3W gives me 3W squared. W times 1 gives me W. Now what I want to do is make sure that I'm setting it equal to 0 by taking the 52 to this side. I'm going to subtract 52 here, subtract 52 here. That's how I get 0 equals 3W squared plus W minus 52. Ideally at this stage I could factor something out of everything, but when I look at it I see that I can't. That means I'm going to have to use my factoring methods for A is not equal to 1. Here I would do 3 times negative 52, which would give me negative 156. That negative 156 would go at the top, plus W would be really a plus 1 that would go at the bottom of my cross. So I'm looking for two numbers that multiply to negative 156, but that add to exactly 1. Going through, doing my factor trees, I should be able to find that this is really, I believe, 12 times 13, which means I should have a positive 13 and a negative 12 for how I split this. If I split it into a positive 13 and a negative 12, I believe it works out properly. And I would get 3W on the outside when I factored 3W plus 12W. And then I'd get 13 on the outside when I factored when I factored 13W minus 52. 13 would come out of both and leave me with a negative 4. Basically, where I'd end up, outsides times insides is 13W, or 3W plus 13 times W minus 4. Again, I'd want to consider what makes each of these 0. So if I set 3W plus 13 equal to 0, I'd get a negative number, specifically negative 13 over 3. If I set W minus 4 equal to 0, I'd get the correct answer, which is that the width is 4. When I have a width of 4, that's a reasonable number. A negative width doesn't make sense. So here I've solved and said that the width must be 4. For that reason, I can plug it into my length formula to find the answer for length. 3 times W plus 1 becomes 3 times 4 plus 1. 3 times 4 is 12, plus 1 gives me 13. So the dimensions of the rectangle are 4 centimeters by 13 centimeters. For the questions I ask you, it usually stops there, asking for dimensions. Here they go one step further and say if I have those dimensions, I can use a formula for perimeter to find the perimeter. Specifically, the perimeter of a rectangle is 2 times the width plus 2 times the length. So they go to the extra step of saying, well, let me take 2 times 13 plus 2 times 4. That would give me 26 plus 8, which gives me a final answer of 34 for the perimeter. If you want more problems like this, more specific to the way that you're going to see it in the homework, I highly recommend you look at the classwork video. In that I solved out 5 problems like the ones that you're going to see on the homework. So the final answer, if I had a rectangle with dimensions 13 by 4, it would have an area of 52, which is a situation where if I take the width, it's 3 times as long to get plus 1 to get to the length. So all of it checks out. The perimeter is correct at 34.